In this video, we will prove that the sum of the first n terms in a geometric sequence, which I'm going to call S sub n, is equal to a times 1 minus r to the power n all over 1 minus r. Recall from the last video I made about geometric sequences, which I'll link in the top right of the screen right now, that the general form for a geometric sequence is a times r squared, a times r cubed, and so on. And that the nth term in a geometric sequence, a sub n, is a times r to the power n minus 1. The sum of the first n terms, s sub n, then, must be equal to a plus a times r plus a times r squared, and so on, until you get to the nth term, which we established was a times r to the power n minus 1. Now here's the clever part of this proof. Let's take this equation and multiply both sides of it by r. On the left-hand side, we would get s sub n times r. And on the right-hand side, multiplying by r means that we need to raise the power of r in each term by 1. So a becomes a times r becomes a times r squared becomes a times r cubed, and so on. Until the last term, a times r to the power n minus 1 becomes a times r to the power n. And if we subtract the equation on the top from the equation on the bottom, we get, on the left-hand side, s sub n minus s sub n times r. And on the right-hand side, if we subtract, notice that a lot of terms cancel. The a times r terms cancel. The a times r squared terms cancel as well. In the equation on the top, after a times r squared, we would have a times r cubed, and that would cancel with the a times r cubed term in the equation below. And this process would repeat until the only terms we have left are this a term in the top equation and the a times r to the power n term in the equation on the bottom. Every other term in between can be found in both equations, and so when we subtract, they cancel. So ultimately, what we end up with on the right-hand side is a minus a times r to the power n. If we factor out s sub n from the left-hand side, we have s sub n times 1 minus r, and if we factor out a from the right-hand side, we get a times 1 minus r to the power n. And if we divide by 1 minus r on both sides, we get that s sub n, the sum of the first n terms in a geometric sequence, is equal to a times 1 minus r to the n over 1 minus r. And that's all there is to the proof for this formula. Now let's verify this formula with a very simple problem. Find the sum of the first 5 terms in the geometric sequence that begins with 1, 2, 4, 8, and 16. If we use a calculator to perform the sum, we get that s sub 5, the sum of the first 5 terms in this sequence, is 31. Now let's use the formula we went over to see if we get the same answer. We know that s sub n is equal to a times 1 minus r to the n over 1 minus r. We are looking for s sub 5, so n is equal to 5. And recall from my previous video that a is just the first term in the sequence, so it's equal to 1. And the common ratio r is 2, because 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and so on. And if we plug all these values into our formula, we get that s sub 5 is equal to a, which is 1, times 1 minus r, which we found was 2, to the power n, which is 5. So 1 minus 2 to the 5th power, all over 1 minus r, or 1 minus 2 in this case. And so what we have here is 1 minus 2 to the 5th, or 1 minus 32, over negative 1. 1 minus 32 is negative 31, and negative 31 over negative 1 is 31. And so we verified that this formula works.